Hello, 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 guys. Am I audible to you all? Hello, guys. Hello, hello, guys. Hello. Please respond if I'm audible. Okay. Thank you, Ash. So, hi everyone. Welcome to the PCD of today's Code Forces round, which was Educational CF round 178, and we'll discuss the first five problems. That is from A to E. All right. So let's begin. So before I start with the PCD, I would like to tell you about our CP31 sheet. So, for all those who don't know, this sheet contains 31 handpicked problems from all the ratings from 800 up to 1900. And the problems are specially handpicked so that each problem teaches a unique idea. All right. And also, you can connect your CF account to this sheet. So, it will automatically fetch your submissions and tell you which ones you have done already. And also, there is a leaderboard section where you can compete with the friends about who solves more problems, and there is this discuss section right here where you can discuss the problems with your peers, right? So yeah, let's begin with the VCD. I'll move to problem A. Right, so today's contest was pretty easy. Like, many people solved till E, or maybe it was cheating, I don't know. All right, so the problem A says that Monocarp plays three decks of cards in a row on the table. The first deck of cards consists of A cards, the second deck consists of B cards, and the third deck consists of C cards, with the condition that A is less than B, less than C. Monaka wants to take some numbers of cards, at least one, but no more than C, from the third deck and distribute them between the first two decks so that each of the taken cards ends up in either first or second deck. It is possible that all cards taken on the third deck will go to the same deck. Your task is to determine whether monocarp can make the number of cards equal using the district operation. Right. So, um, what you have is you have three decks of cards: a deck A, a deck B, and a deck C, where you have some cards. Like, let's say on A you have two cards, on B you have three cards, and C you have four cards. So what you want to do is that, okay, and it is given that A is less than B, which is less than C. So the number of cards in it are in this order. So what you want to do is just take some cards from C and put them in either A or B. Like, distribute them between A and B. You might give some cards to A, some cards to B. Or maybe you can give no cards to A also, or you can give no cards to B also. It's up to you. Right. So in the end, you want to make all three piles have equal number of cards. Okay. So this is what you have to do, and you have to tell them if it's possible or not. So I think this is a pretty simple problem. Like, what you can just do is that, first of all, you want to make these two equal, right? At any cost, you want to make these two equal. So obviously, you will have to pick up some cards from C and put them into A until they become equal, right? So whatever the difference between A and B, C must be greater than that, right? C must be at least that, the difference between A and B. So if that is not the case, then we'll say no, right? So if C is less than B minus A, then we'll say no. Okay. Then what we will do is we transfer some cards from C to A. That is, like, let's say difference is equal to your B minus A. So what I'll do is I'll add diff to A, or basically I'll set A to B, and I'll subtract this diff variable from C. C is equal to C minus diff, right? So now I have the same number of cards in A and B, right? And what I want is the same number of cards in all three decks, right? So now what I'll do, I will just take some cards from C and distribute them onto A and B. But for that, actually, it has to be that, like, at this point, C must not be less than A. Like, for example, if I say that, let's get an example. Wait, I'll think of an example. Say we have 2, 4, and we have 3, right? So what we'll do is first, wait, this is invalid because, okay. So, anyways, like, I don't know the example right now, but what I'm saying is that, um, like, once you have transferred these cards onto this pile, like, let's say you transferred diff number of cards onto pile A from pile C. Now, at this point, if the pile C contains less than pile A, then you will say no, because you want to make them equal, right? You want to make them equal, and you can only remove from C. You can only remove from C and add into A and B. So, if you see that the number of cards in C is less than number of cards in A, then you will say no. And then what you will just do is check that, see, in the end, you want that every one of them should have equal number of cards. Let's say X, X, and X. So, of course, your total number of cards should be multiple of 3, right? So, A plus B plus C should be multiple of 3. So, mod 3 should be equal to 0. So, just check this condition. And if it is so, and C is not less than A, like C is at least A, then your answer will be yes. Okay. Yeah, so this is the thing, like, this is the solution right here. So do you want to tell me a sample test case? Okay, I'll just tell one for your sake. So let's say we have 12, 20, and 30. So in this one, the sum is not divisible by 3. So therefore it is no. And this one is yes. Let's see why, because actually in this case we can just move two cards, like the difference from this 7 to this 3, so it will become 5, 5, 5. And this is no, because like, when you do 1 5, when you take 1 5 6, when you remove 4 cards from this one, like, the difference is 4, right? So when you remove 4 cards from this one, this will become 5, 5, and 1, 5, 5, and 2, I mean. So since C is less than A at this point, you will not be able to do anything. So this is why the answer is no. Okay. All right. So yeah, this was the answer, and I'll just show the code for the sake of it. So int ABC, C in ABC, the difference is equal to T minus A. And what I'll do is I'll add this difference into A and subtract this difference from C. Right? If now C is at least A and their sum mod 3 is 0, then we print yes. Otherwise, we print no. Okay. Shraddha is saying we can just take the average and check if A and B is less than average or not. Okay, that also works. Because if any of them is greater than the average, that means C is less than the average. And also we cannot reduce it. Yeah, that is also fine. You also have to check that average is integer value. Right? Anyways, so I'll move on to problem B now. Move to the end. You are given an array A consisting of n integers. For every integer k from 1 to n, do the following. Choose an arbitrary element of A and move it to the right end of the array. You can choose the last element, then the array won't change. Print the sum of k last elements of A. Move the chosen element you have chosen on the first step to its original position. That is, restore the original array A. For every k, you choose the element which you move so that the value you print is the maximum possible. Calculate the value you print for every k. Okay, so our problem says that we have three numbers, or sorry, we have like n numbers. That is an array. We have a1, a2, a3 up to an, right? And also, let's say we have an integer k. Like, let's say for now, we are solving for integer k, and what we will do is we will select any number. We will select any element from the array, right? And we'll send it to the end of the array, right? And then what we will do is we will just print the sum of the last k elements, right? We will print the sum of the last k elements. So basically, what we'll print is a of n minus k plus 1 plus a of n minus k plus 2 up to a of n. So this is what we'll print after moving this a2 to the end. So this a of n becomes a of n minus 1. Like, not just a2, we can choose any value to move to the end. And we have to solve this problem for every k. That what is the answer to this problem, and just print it, like just print n values for each test case, right? So if we have 7 values in the array, then we have to print for the answer for k equal to 1, k equal to 2, k equal to 3, and so on, right? So let's now look at some samples to better understand what's going on. All right. So let's say here we have this. I'll just take random 5 numbers, okay? Let's say I have 12, 15, 3, 4, and 20. Or let's take 10. Okay. So for k equal to 1, what you will do is just choose one number. Just choose one number and push it to the end. And then you will print that number. So basically, essentially what you're doing is just choosing one number and printing it, right? Because moving it to the end and then printing it is same as just printing it. So what you will do is just print the maximum value, right? Correct. Now let's say we solve for k equal to 2. So let's say you move an element from some position to the end. So let's say you move this element to the end, so it becomes 15, right? And then you will take the sum of the last two elements, right? So as I can see that the last element is of course the one that I moved, right? And the rest of the elements, like the other element, is in the original array, whatever was at the last position, right? Like when I move one element and I solve for k equals to 2, then the last element is what I have pushed to the end, and the other elements are what they were in the array, like at the end of the array. So in general, if I say, like for example, in general, for an array, if I say that if I have a1, a2, a3 up to an, and let's say I push ai to the end, right? So my last elements, like let's say I have pushed some ai to the end, so my last k elements will consist of these like the first, basically these are k-1 elements, right? So the last k-1 elements of my array, right? And also the element that I pushed, the element I pushed, right? So this will happen. So like one thing is clear, that these elements won't change, right? But actually I can also push um, some element which is already in the end. That's also a thing. Like I can actually push some element already in the last k elements. Like for example, if I have these numbers 1, 15, 3, 4, 10, sorry, 12, 15, 3, 4, and 10. So possibly when I'm doing solving for k equal to 4, I could also theoretically send this 15 to the end. Or let's say my 15 was here and here was 3. So I could also theoretically push this 15 to the end, right? But that has no point. Like, that has no point because 15 was already about to come. Like, when you were solving for k equal to 4, right? When you're solving for k equal to 4, the last three elements will definitely come already. Like, the last three elements will definitely come by default. And whatever you do, they will definitely come. And like, out of these elements, you can choose. Out of these remaining elements, you can choose that which one of them do you want to push back to the end. Like, which one of the elements do you want to take. So let's say you can take this 12 also. So like, my point is that pushing any of the last k minus 1 elements has no purpose, because whatever you push, these elements are obviously going to be there anyways. So you would just try to push something else, like, before this boundary. So either you push 12 or you'll push 3, and then whatever you push, that will come, and these three elements will come. Like, if I solve for k equal to 4, so the last three elements will come in my sum, and this element will come in my sum. So essentially, what I'll just do, I'll just take the maximum of this prefix, right? Until here, whatever the maximum is, I'll take that. And so that element will come, and the last k minus 1 elements will also come. The last k minus 1 elements, they will also come, and my answer would be just the sum of last k minus 1 elements, inka sum, plus the prefix mix, I mean the prefix maximum. Like, whatever is the maximum element on this prefix, that is I'll add to my sum. So like, if I show it on this test case, like, let's say I want to solve for k equal to 4 on this test case. Okay, so I'll copy this thing and paste it here. uh Wait, never mind. So let's say I have 13, 5, 10, 4, 8, 15 and 13. So let's say I want to solve for k equal to 4, right? So what I'll just do is, I'll take the last k minus 1 elements, like last three elements, and so they are sum, because they will definitely come in my sum. And I'll take the first four elements, and I'll choose the maximum one, right? So that's my answer. Like, 8 plus 5 plus 8 plus 15 plus 13 plus 13. That's my answer. All right. So that is your answer. So in general, if I say that for k equal to I, if I want to solve for k equal to I, or let's say for k equal to 1, my answer would be the sum of like last zero elements. Like, so basically 0 plus the prefix max of 7. So like, if I index this 1, 2, 3, 4, 5, 6, 7. So I am saying that pref of I means the maximum element from 1 to I. Okay. So let's say you want to solve for k equal to 1. Then that is the answer would be the sum of last zero elements plus the prefix of 7. Like, the maximum element in this. Then let's say you want to solve for k equal to 1. So let's say you want to solve for k equal to 2 now. So that would be the sum of the last one element plus the prefix till 6. Then let's say I want to solve for k equal to 3. So that would be the sum of the last two elements plus the prefix max till prefix maximum, I mean prefix maximum till 5, and so on. So this is a pattern. So what you can just do is just iterate. Like, first of all, just calculate these prefix max values, and just iterate from left to right. I mean, sorry, from right to left, and maintain a running sum. So initially it is 0 and plus prefix of 7. So like, you are starting the I from 7 down to 0. So 7, 6, 5, and while doing that, you will also update a sum. So when you print this 0 prefix 7, you will also add this a of 7 into your sum, and that's what you can do. Okay. Turvike, like if that's your name, like if I may call you that, that is also fine. You can use a set and erase the elements. I mean a multi-set, not a set. Um, Cricket lover, first element is maximum and last is total. How to place middle element? So cricket lover, I'm not getting what you are asking. Does someone has a doubt? Like, does someone else have a doubt in this? Okay, Mohit. Thank you, Pradeep. No worries, Mohit. Like you solved using set, that's also fine. All right. Although this is an O of n and yours is O of n log n, so maybe in your DSA interview you might uh, be asked the O of n solution, but on CF it is no problem. Okay, so I'll show the code now. So you have int n, c in n, and I'll take the input of the array n, array a, right? And here I have the prefix minimum, or I mean the prefix maximum, right? So the first element will be just a0, and for int I equal to 1, I less than I plus plus, my prefix maximum of I will be the max of the prefix maximum till I minus 1 and a of I. So if a of I is greater than all of the elements before it, then I will set pre of I to that. Otherwise, my pre of I will be pre of I minus 1. And I have a running sum variable. So I'll iterate from the last index to the first index. So for int I equal to n minus 1, I greater than equal to 0, I minus minus. I'll just see out sum plus prefix max of I. And also then I'll increment this sum by a of I. Okay. So yeah, this is the code. Cricket was asking, first element is always the maximum element in the array, and last one is the total sum. How the rest numbers are going to place? Like I still don't understand what you are saying. First element is always the maximum element. This is wrong statement. Like I really don't understand what you are saying. Like I think what I'm understanding, that's definitely not what you mean. So I'll try to move on. Like in the array, the first element is not the maximum element. Maximum element can be anywhere. I don't know what you are saying. Sorry. Anyway, so I'll move on to the next problem, which was C, card game. Right. So Alice and Bob are playing a game. They have n cards numbered from 1 to n. At the beginning of the game, some of these cards are given to Alice and the rest are given to Bob. Card with number I beats the card with number j if and only if I is greater than j. With one exception, card 1 beats card n. The game continues as long as each player has at least one card. During each turn, the following occurs. Alice chooses one of her cards and places it face up on the table. Bob, seeing Alice's card, chooses one of his cards and places it face up on the table. If Alice's card beats Bob's card, both cards are taken by Alice. Otherwise, both cards are taken by Bob. A player can use a card that they have taken during one of the previous turns. The player who has no cards at the beginning of a turn loses. Determine who will win if both players play optimally. right? So um, what the problem is that we have like n cards, right? From 1 to n, from 1 to n, and some cards, like what I'm saying is that some cards are with Alice and some cards are with Bob, right? And all the cards have been distributed. Okay, so there's no card which is not with either one of them, right? So, and what is that? Like, basically, they're playing a card game. So, first, each turn, Alice will throw a card into the pile, and then Bob will see that card, and then Bob will throw a card according to his, like, his choice upon seeing this card, right? And then whoever's card is bigger, they will take it, except for 1 and n. Like, if Alice throws 1 and Bob throws n, then 1 wins. Like, between 1 and n, 1 wins. And except for that, between I and j, between I and j, the maximum 1 wins. Like, if I is greater than j, then I will win. Otherwise, j will win. Alright. So, this is the game. And like, turn by turn, they are playing the card. So, Alice will play a card, then Bob will see that card and play a card. So, whoever, like, okay, and then whoever wins will get those two cards, right? So essentially they have gained a profit of one card, like they have gained one card, and the other one has lost one card in this turn. So whoever just finishes all their cards, whoever turns out, like, what's that phrase, whoever runs out of their cards on the first, that person will lose. So they are asking that if both players play optimally, then who will win, right? So, like, let's say that we have A and B. So that means that Alice has card 1. Alice has card 1 and Bob has card 2, where 2 is equal to n. So when Alice plays 1, Bob will play 2. And since 1 beats 2, Alice will win. Right? So that's why the player is Alice. Like, at this point, Bob has no more cards left. So that's why Alice is the winner. Then for BA, similarly, Bob is the winner. And the rest of them I'll not discuss. I'll just tell the solution. All right. So, what they are actually doing. So let's analyze the situation. Like, okay, you have the cards from 1, 2, 3, 4 up to n, right? So what we know is that the card I will beat card j if I is greater than j, except for the card 1 and n. Here 1 will win, right? So basically that the card n is kind of the most powerful. The card n is the most powerful, except for the fact that it gets beaten by 1. Like, all the other cards, it can beat except for 1. So all the other cards except for 1, it can beat, right? So 1 is actually very powerful also. So 1 is also powerful and is also powerful. So let's say that if some player has both 1 and n, if some player has both the cards 1 and n, then I'm claiming that they'll be the winner. They will definitely be the winner. Why is that? Like, I'll show you why. So let's say that Alice has both 1 and n. Let's say Alice has both 1 and n. So what can Alice do? Alice will simply play all their cards. I mean, sorry. Alice will simply play n. Alice will simply play the card n. And then what can Bob do? Bob actually cannot do anything because the card 1 also with Alice only, and card n also with Alice. So Bob actually cannot beat this n. Like, whatever Bob plays, he will lose. Whatever Bob plays, let's say card k, he will lose, and both of these cards will come to Alice. So if Alice is winning every turn, that means eventually Bob will run out of cards. Like, definitely Bob will run out of cards and he will lose. So that's why if Alice has 1 and n, if Alice has 1 and n, then Alice will win. Right. Now what if Bob has both 1 and n? If Bob has both 1 and n, then what can he do? Then see, Alice will play something, right? Alice will play something on the deck. So here is Alice, and she will play something. And whatever she plays is definitely between 2 to n minus 1. Like it is neither 1 nor n, because that is with Bob. So Alice cannot have it. So Alice will play any card from 2 to n minus 1, and then Bob can simply play n. Bob can simply play the card n, and he will win any card that is thrown by Alice. So he will win that. Bob will win every turn, and hence all the cards will eventually come to Bob. So therefore, the Bob will win the game. So Bob wins. If 1 and n are with Alice, then Alice wins, and if 1 and n are with Bob, then Bob wins. Now, what are the other cases? Like except for this, what are the other cases? The other cases there, one player has 1 and the other player has an n, right? So one of the players have a 1. So let's say Alice has a 1 for now. Like let's say Alice has 1. Alice has a 1 and Bob has the card n, right? So now what will do? Like what will Alice do? See, first of all, just like observe that Alice knows that what cards Bob has, because whatever cards she doesn't have, those cards Bob has. Like I think it might be given also. Okay, it is not given, but we can assume that Alice knows that which cards Bob has, because whatever cards Alice doesn't have, those are the cards that Bob will have, and both of them know the value of n. Okay, so that's why Alice knows that what cards Bob has. So what she can do, like if Alice has 1 and Bob has n, then what can she do? Now let's say Alice plays. Okay, now Alice has two options. Either she can play 1 on the first turn. Either she can play 1, or she can play non 1. Like she can play something other than 1. Play non 1, right? So let's see what will happen in both the cases. So let's say that she plays non 1 card. Okay, if she plays non 1 card, then definitely Bob can just play n, and then he can win. He can win that hand. So definitely this is not optimal for Alice. Like she is just losing a card with no reason, right? So in this case, like if Alice plays a non 1 card on her first turn, then Alice will lose. Like not Alice will lose, but that is not optimal, because she's just giving away a card for free. And if Alice plays a 1, okay, if Alice plays a 1, then what will Bob do? Then Bob will just play a card. Bob will just play any card other than n. Okay, like because if Bob plays n and Alice has played 1, then of course 1 will win. So Bob won't do that. Bob will just play any other card other than n. So like between the cards 2 to n minus 1. Between these cards 2 to n minus 1, Bob will play that card, and he will win this one. So at that point, Bob will possess both n and 1. Like after Alice plays 1, if Bob will just play any card other than n, then Bob will possess both n and 1, because this 1 will come to Bob. So after this, Bob will get n and 1. Bob will get both n and 1. So what does that mean? That means Bob will win. That's what I proved up of. Like that's what I proved up. That if Alice has both n, 1 and n, then Alice wins. And if Bob has both n and n, then Bob wins. So if Alice has 1 and Bob has n, then if Alice plays a non 1 card, then Bob will just play n. And if Alice plays a 1 card, then Bob will play something other than n. And then he will win. But what if he doesn't have any card other than n? Like what if he only has n card? Like what if, my point is that what if Bob doesn't have any card other than N. Okay. So if Bob doesn't have any card other than N, then of course he'll have to play N. Like once Alice plays one, then Bob will have to play N, and therefore he will lose that turn. So N will go to Alice, and at that point, uh, both the cards are with Alice. Like both 1 and N will be there with Alice, and therefore she will win the game eventually. So if Bob has only N, then Alice will win, and if Bob has any other card, then Bob will win. If Alice had 1 and Bob had N in the beginning, right? So this is the case if Alice has 1 and Bob has N. So like I'll just write it that if Alice has 1 and Bob has N, then we can say that Bob will win if he has any other card, right? Else Alice wins. Like, otherwise, Alice wins, and it is game over for Bob. So till here, does anyone have a doubt? Just tell me that. Like, I think these two must be clear that if both of them, like, if any one of them has both 1 and N, then they will win. And this case, if Alice has 1 and Bob has N, then does anyone have a doubt in this case that what is happening? Raju is saying if Alice has 1, then she should throw 1 every time and Alice will win. No, that is not correct, Raju. Because let's say that Alice has 1. If Alice has 1 and Bob has 2 and 3, then when Alice throws a 1, so Bob will throw 2. Okay. And 2 will beat 1. Because here N is equal to 3. And in the problem they are saying that I will beat J if I is greater than J. Except for 1 beats N. Like it doesn't say that 1 beats every other card. 1 only beats N. And every other card beats 1. That's what the rules are. That 2 will beat 1. 2 will beat 1. Okay, Raju? Right. So this is what I am saying you. So if Bob has any other card other than N, then he wins. Otherwise, Alice wins. Now the last case is that what if Alice had a card of N and Bob had a card of 1? Okay. So in this case, what can she do? Now, again, she has two options. That either she can play the card N, she can play N, or other option is she can play 1. Sorry, not play non N. Right. So either she can play N or she can play non N. So let's look at both of these cases. So if she plays an N, okay, if she plays an N, that means that like it will be countered by Bob. Bob will play 1. Bob will play 1 and he will win. Like Bob will win. Bob wins. So that is not optimal. So Alice will never do this. Okay. So Alice will definitely play a non N card. Right. Alice will play a non N card. So now, which card does she play? Now let's say that she plays some card which is like, let's say N is 5. Okay, let's say N is 5. So that means 1, 2, 3, 4, and 5 cards are there. Let's say Alice has 5 and Bob has 1. That we already know. But what about the other cards? Alice has 5, Bob has 1. So on the other cards, let's say that Alice has 2 and 3, and Bob has 4, right? So now we have concluded that Alice cannot play 5. Alice cannot play 5 because then Bob will play 1 and then she will lose. So Alice will play either 2 or 3. Okay. She'll play either 2 or 3. But as soon as she plays 2 or 3, Bob will play a 4 and Bob will win that card. Right. So actually she cannot even play anything because the card n minus 1 is with Bob. Like she cannot play n and n minus 1 is with Bob. Like if n minus 1 is with Bob, then whatever else she plays, Bob will just play n minus 1 and then the game will end. Like not end, but Bob will keep playing n minus 1 until Alice runs out of cards, and eventually Bob, like Alice will have to play the end and Bob will play 1. So if Bob has n minus 1, if Bob has n minus 1, then he wins. Else Alice wins. Okay. So this is the case where Alice has n and Bob has 1. So of course she cannot play n. So she'll have to play n minus 1. But if she doesn't have n minus 1, then whatever she plays, Bob will play n minus 1. So Bob will win. And like let's say she has n minus 1. Let's say that she has n minus 1. Then she will keep playing n minus 1, minus 1, minus 1. And Bob will have to play something which is less than n minus 1. And whatever Bob plays, even if Bob plays 1, he will lose because n minus 1 will beat 1 every time. Right? So Alice will just keep playing n minus 1, and whatever Bob plays, he will keep losing the cards, and eventually he will lose the game. Okay. So this is the solution for problem number C. So do you all get this? Pradeep gets it. Okay. Raju gets it. Does anyone have a doubt in this? They can ask right now if they have a doubt. Okay, I'm assuming that no one has a doubt, so I'll move on to the code. In the code, what you have is we have this int n c in n, string s c in s. If s of 0 is equal to s dot back, that means the last element of s. So that means on the first element, like the card number 1 and the last card is with same person. Then if it is with Alice, so Alice wins, and if it is with Bob, then Bob wins. Okay. Now otherwise, if card 1 is with Alice and card n is with Bob, so this is this case that card 1 is with Alice and n is with Bob. So Bob will win if he has any other card other than n. So what we'll do is just count the number of cards that Bob has. So count s dot begin, s dot end, and b. So if that is 1, like that is equal to 1, that means that Bob has only one card, that is n. So Alice wins. Otherwise, Bob has some other card, so Bob wins. All right. And the last case where Alice has card n and Bob has card 1. So I'll first, like, I'm handling n equal to 2 case because like I'm commenting on 3 cards, right? I'm commenting on 3 cards, 1, n minus 1, and n. But if n equals to 2, then this two numbers become equal. So I am just handling that case like alag se, separately. I'm handling it. So if n equals to 2, and basically if Alice has If Alice has 2 and Bob has 1, then Bob will win. And if n is greater than 2, then of course that logic that if like whoever has n minus 1, they will win. So if s of n minus 2 is a, that is if Alice has n minus 1, then Alice will win. And if Bob has n minus 1, then Bob will win. Okay. So this is the code for C problem. I hope you all understand. Okay. Yash Gehlot, reserve means that vector will allocate that much memory which you are telling it to allocate. Like if you do without reserve n, then it will allocate memory for n elements, but it will not change the size of that vector. Like it will simply allocate that memory into the RAM, but it will not change the size of the vector. So if you do without size, then it will show the previous size, not n. And you can look it up on GFG as well, Geeks for Geeks. Like what does vector without reserve do? Anyways, so I'll move on to problem D. Problem D says array and GCD. You are given an integer array A of size n. You can perform the following operations any number of times. Pay one coin and increase an element of the array by one. You must have at least one coin to do this operation. Gain one coin and decrease any element of the array by one. So basically, either you can decrease any element of the array and gain one coin, or you can pay one coin and increase an element of the array by one. Let's say that an array is ideal if both of the following conditions hold. Each element of the array is at least 2, and for each pair of indices I and j, the GCD of ai and aj is equal to 1. If the array has less than 2 elements, then the condition is satisfied. Okay. Let's say that an array is beautiful if it can be transformed into an ideal array using the below before operations, provided that you initially have no coins. If the array is initially already ideal, then it is also beautiful. The given array is not necessarily beautiful or ideal. You can remove any elements from it, including removing the entire array or not, including and removing the entire array, or not removing anything at all. Your task is to calculate the minimum number of elements you have to remove from the array A to make it beautiful. So basically, the problem is having three parts. Okay. So the first part is that what operation can you do? You can just do this operation that you can either decrease an element and gain one coin, or you can pay one coin and increase an element of the array by one, both of them by one. Now you want to make the array such that the GCD of any pair of elements is equal to 1. Okay. And also each element is at least 2. Like you cannot make the element as 1, or you cannot make them negative also. All right. So you want to ensure that the GCD of every pair of integers or elements is equal to 1. And the array is called beautiful if you can do it. Like the array is called beautiful if it is possible to convert that array into this array using this operation, right? The given array is not beautiful or ideal, but you can remove any number of elements, okay, to make it beautiful, right? So that's the problem, that you want to make the array such that you can convert it using the operations. So what does that mean? That for example, your 555 is what? It is beautiful because you can do this. Like let's say you have 555. So actually this is beautiful because you can simply decrease an element. Like let's say you decrease this element, so you make it 455, and currently you have one coin. And let's say you increase, um, what you can do is, wait, Okay, yeah. So let's say you have 4, 5, 5, and let's say you decrease it one more time. So you will have 4, 4, 5. So you will have two elements, two coins, I mean, and then again you decrease this element. So you will have 4, 3, 5. So you have three elements. So I mean, you have three coins. So at this point, you have three coins, and your array has become this. Your array has become like this. So finally, actually, this array, as you can see, it is beautiful. So I mean, it is ideal. It is ideal. And what does ideal mean? Ideal means that all of the elements pair, like all of the pair of elements, GCD is at least like is equal to one. I mean, the GCD of AI comma AJ is equal to 1. Okay, this is your ideal array, and you have made this 555 as ideal. Okay, and like you end up with some coins, so that doesn't matter, but you shouldn't have at any point negative number of coins. Like you cannot have negative coins. So in order to increase an element, like to increase an element, you have to have at least one coin. But it is possible that you end up with some number of coins. That is okay. So yeah, you have made this 555 into this 435, and this is ideal, right? So your task is like, I basically you can, like, in the given array, from the given array you can remove any number of elements, and you have to ensure that it is beautiful. And beautiful means that it is possible to convert it into an ideal array using these operations, right? So for example, even this third one, this is also beautiful, because like you have 200 and 2, right? So what you can just do, you can, let's say you do 299 and 2. So you have one coin, like you decrease it, so you have one coin. Then let's say you increase this 2, so you give 1 to 2, so you'll have 299 and 3, right? And then let's say you decrease this 99 to 98, so you will have again one coin, and then to 97, so you will have two coins. So finally your array becomes 2, 97, and 2 and 3, I mean. So as you can see that each pair of numbers has GCD equal to 1. The GCD of AI comma AJ is equal to 1 in each pair of numbers. So that's why like you are able to convert this array into this array. So therefore this array is ideal, this array is called ideal, and this array is called beautiful. And you want, so therefore the input array, it is beautiful. That's why the answer is 0. Like you don't need to remove any elements from the array to make it 0. All right. So yeah, that is what the problem says that you have to do. All right. So now actually how do we think about this? Just first of all, let's think about this operation. Like what does this actually do? So the thing is that you can pay one coin and increase any element, and you can gain one coin and decrease any element of the array. So my claim is that, let's say that you have any array a1, a2, a3 up to an. You have n elements and you have this array. My claim is that you can convert this array into any other array of the same length, like with a condition. Okay, so you can convert this array into any other array of the same length with a condition. And what is the condition? I'll tell you. So b1, b2, b3, sorry, b3 up to bn. So you can convert this array into any other array of same length, provided that, let's say, this sum is capital A. If the sum of these elements is capital A and the sum of these elements is capital B, then if my B is less than or equal to A, then I can actually convert this array into this array. Like give me any two arrays and I will be able to convert them. If their sum is less than, like the sum of B is less than sum of A. That's what my claim is. And like how do I know that? Actually, basically, if you can see that what is happening in these operations, just observe this, that like you decrease any element and your number of coins increase by 1. Like your number of coins increases by 1 and you decrease the element by 1, right? So that means that your sum, like the sum of the array plus the number of coins that you have, it remains constant. Like, right, like for example, you had the example of 555, right? 555. So if you reduce it to 455 and you have one coin, so initially this sum was 15, but since you reduced one element, so the sum became 14. But you have now one coin, so the sum of the array plus your number of coins is still 15, right? And let's say you increase this, let's say you increase this 5 to 6, so let's say you have 4 5 6, and again if you find out the sum, so 15, and actually since you increased, your coins decreased by 1, so they became 0. So again your sum of the coins and the array is equal to, like, it's conserved. So initially it was 15 and it will remain 15, right? And since your number of coins cannot become negative, right? Your number of coins cannot become negative, so that's why this sum, like the initial sum was 15 of the array, so like initially it was 0, so you cannot actually increase this sum, because otherwise you have to decrease this value, and you cannot decrease it anymore because it is already 0 and you cannot make it negative. So therefore the initial sum, whatever it is, the final sum also has to be less than equal to that, and you can make any array which has the sum less than equal to this array. So like whatever array you give me, like let's say I have 1 1 1 1 1, okay, or not this array. Let's say we have 3, let's say I have 5 threes, and I want to make um 11 1 1 1 1, okay. So actually I can make this. Why? Because the sum of this is 15 and the sum of this is also 15. So since it is less than equal to the initial sum, I can make it. And how do I make it? I can simply just decrease all of the elements, whatever I want to decrease, right? So I will have 8 coins till now by doing these operations, and those 8 coins I can spend here and make it 11. So actually I can always transform this array A into array B if the sum of the array B is less than equal to sum of the array A, by just decreasing it by decreasing all the elements which needed to be decreased, and then increasing all the elements which need to be increased. So in that way you can make any array, okay, but you can't decrease any element below 2. Yes, but okay, so not any array, I am talking about any array such that all of its elements are at least 2. Okay, so any array which I have, which has all the elements at least 2, I can convert it to any array which has all its elements at least 2. So this is what my claim is, okay? My modified claim, like any array which has all of its elements at least 2, you can convert it to any array which has elements at least 2. All right, and your input array has all the elements at least 2, so it doesn't matter. Okay, Pradeep. My new claim is that given any array whose every element is at least 2, you can convert it into any array whose every element is at least 2, provided that its sum is less than equal to sum of A. So do you all get this point? Do you all get my claim and the proof of my claim? How I am converting this array? Yeah, so but the problem is not over, right? The problem is still not over. Like what you have to actually do now is like convert this array into a beautiful array, right? You want to convert this array that you have into a beautiful array, and if you cannot do that, you have to tell them that how many elements should you delete in order to convert your array into a beautiful array. right? So like, yeah, how do I actually do that? How do I know that can I convert my array into a beautiful array? So okay, simply what my task is, that I want to convert my a1, a2, a3 up to an into a new array, b1, b2, b3 up to bn. Okay, and what you have to ensure that this bn, like this b array, has to be beautiful. And beautiful means that the gcd of bi comma bj should be equal to 1, right? So how do you actually achieve this? Now I said that if b is less than equal to a, that is the sum of this array b is less than equal to sum of this array a, then you can make it. Like then you can possibly make this array. Like if you find any beautiful array whose sum is less than equal to the sum of this array, then you can definitely make that array using the operations. Like your task is just to, like your task, new task, has boiled down to just find any beautiful array, any beautiful array whose sum is less than equal to a, right? So and if you cannot do that, then you cannot convert this array a into a beautiful array using the operation given above. So your task is to find any beautiful array whose sum is less than equal to a. So basically you have an upper limit on sum, you have an upper limit on the sum of your final beautiful array, right? And so actually, if we try to just make an array which is beautiful and try to make the sum minimum possible, like if we try to make the minimum possible sum of the beautiful array, then if that sum, if that is still greater than a, then of course we can say that we cannot make it. Like let's say that if I find a beautiful array with the minimum sum, so let's say I find an array s1 s2 up to sn, and this apparently has the minimum sum s out of all possible beautiful arrays. So if s is still not less than a, that is greater than equal to a, I mean greater than a, then we can say that a cannot be converted into a beautiful array, right? So what we can try is to find out the minimum possible sum beautiful array, the minimum possible sum beautiful array. So how do I do that? Just remember that what is a beautiful array. My b1, b2, b3 up to bn is called beautiful if gcd of bi comma bj is equal to 1, right? So now what I can say, that means that, and also what there, like bi is greater than equal to 2, like no one is at least 1, like no one is 1, right? They are at least 2. So what I can say is that every element should have a distinct prime number. Like there should be no common prime factor between any of the elements. Like for example, if b1 has 2 as a factor, then no other element in the array can have 2 as a factor, right? And let's say it also has 3 as a factor, then also any other element in my array cannot have 3 as a factor. And also every element should have at least one factor, because it cannot be one. So if my, since my element is greater than 1, it definitely has at least one factor, at least one prime factor in fact. So um, that's my point is, like if b1 has 2 as a factor, then b2 cannot have 2 as a factor, like any other element cannot have 2 as a factor. So I'll have to choose at least 3 to be its factor. And since we want that the sum is the minimum, the sum of this array is the minimum, so I will try to put the minimum possible elements. Like I'll try that the elements are minimum possible. So what I can just do, I can just say that okay, let's say that b1 is 2, Like 2 is the smallest prime number, so I'll make it 2. Now B2 cannot contain any factor 2, so let's say it is 3. Now B3 cannot contain any factor 2, so of course we cannot give it 4, right? We have to give it 5, the next prime number. Then B4. B4 cannot be given 6 because it has 2 and 3, so we have to give it 7, right? So as you can see that my minimum possible array, which is beautiful, is simply the first n prime numbers. Like the minimum sum will be given by the first n prime numbers, that is 2, 3, 5, 7, 11, 13, and so on. So the first n prime numbers, they will give me the minimum possible sum, and that is what I'm looking for. So if the sum of these elements is less than or equal to the sum of my array, the sum of my array, then I can say that this array A is beautiful. Please again. So okay, till where did you understand? Like, did you understand that we want to find the minimum sum beautiful array? Like, we want to find the minimum sum ideal array. I mean, not beautiful array. We want any ideal array. I mean, not beautiful. Sorry. We want any ideal array. We want any ideal array whose sum is less than equal to A. So let's find an ideal array whose sum is the minimum. Like, do you all get? Okay, B less than equal to A. You want that? Okay. So see, I'll give an example. Okay. Like, let's say you have an array which is 5, 4, 9, 2. Okay. So the sum of this is 20. Now Chirag, just try to give me any other array of length 4. Okay. Whose length, like, just give me any other array of length 4 whose sum is at most 20, like whose sum is less than equal to 20. So just give me any array which you think cannot be made. So, like, my claim was that any array whose sum is less than equal to 20 can be made using the operations. So if you did not get that claim, just tell me any array and I'll show you how to make it from this array whose sum is 20. So give me any array. Yes, any array whose elements are at least 2. 2, 7, 13, 16. No, the sum is not less than 20. I want that the final array's sum should be less than equal to 20. Okay, I'm waiting for your response. 6, 7, 2, 3. So you want me to make 6, 7, 2, 3. Okay. So what I told you is that whatever elements need to be decreased, okay, just decrease them. Like, for example, 9 needs to be decreased to 2. So the difference is 7. So just decrease this element 7 times and you will have 7 coins in your bag. Okay. And then just increase the elements which need to be increased. So let's say you need to increase this 5 to 6. So you will take 1 coin here. Then this 4 to 7, you will take 3 coins here. And this 2 to 3, you will take 1 coin here. So you will take 5 coins. So 7 minus 5 is 2. And like basically You had 7 coins and you can spend 5 of them and you can make this array. And finally you will be left with 2 coins. So that's how you can make this array A, make this array B. And you can always make an array by this algorithm. Like, because the sum is conserved, okay? Like your sum of the array. Like let's say you have the array A1, A2 up to AN, right? And let's say sum is A or sum is capital A. And the number of coins that you currently have is 0, right? So when you decrease an element, by 1, the sum decreases by 1 and your number of coins goes up by 1. So the sum decreases by 1 and number of coins goes up by 1. So that means that the total value of the sum plus number of coins is not changed at all. And like when you try to increase an element, like let's say you increase the element, let's say you increase this element, then the sum increases and your number of coins decreases all by 1. So then also the sum is not changed. So since initially you had the array A whose sum was capital A and you had 0 coins. Now you want to convert this into B whose sum is capital B, and finally you would have K coins. So since you cannot have negative coins, so like since initially your total sum is A, so finally if this B's sum is greater than A, then you would have negative coins. So that is not possible. Like for example, if initially your sum is 5 and the number of coins is 0, so what I just told you is that the number of coins and the sum, the total value does not change. So if you try to make us an array of with sum 7, in that case you would have minus 2 coins at the end, which is not possible because you want the total sum to be remain conserved. Okay. So Chirag, do you get this? That you can make any array whose sum is less than equal to A. Like you can always make an array B from an array A whose sum is less than equal to A. Okay. So yeah, since I got that part, so I'll just reiterate what I said, that using the operations, you can convert any array A into an array B whose sum is less than equal to A. And since you want to convert this array A into some array which is ideal, you want to convert this array A into an ideal array. So what you have to do, like if I just find out an array, like if I just find out an ideal array whose sum is less than equal to A, if I just find out an ideal array whose sum is less than equal to A, then definitely I can convert A into that array. I can convert A into that array, right? And so I'll try to find one. So what I'm trying is that the sum of my ideal array should be less than equal to A. So what I'm trying is that I'm trying to minimize the sum. Like what I'll just try is to make the ideal array with the minimum sum. And since my ideal array is defined as, like, if b1, b2, b3 up to bn is an ideal array, then what should I have? I should have that GCD, the GCD of all pairs bi bj, all pairs bi bj should be equal to 1, and all the pairs must be at least 2, right? So that means that all the numbers should not share any prime factor. Like let's say a 2 is there as a prime factor in b1, then 2 cannot be there in b3 or in b2 or in bn. Like in in any number, you cannot have 2 as a prime factor if you have it in b1. So if you want that the minimum sum array is found, like if you want to make the minimum sum ideal array, then of course like you will try to put the minimum elements. So let's say you want to make a 5 length ideal array with the minimum sum. So what you will do is, let's say you put 2 into b1, like because you are at least 2, right? So let's say you just have this prime number 2 as b1, then to b2 you can give the next prime number, the next smaller prime number. Then to B3, you cannot give these two prime numbers, so you will give the next smaller prime number, which is 5. So, and so on. So basically, you are just giving these 5 numbers, or like, okay, I'll write it. B4 will be 7, the next prime number, and B5 will be 11, right? So basically, you are just giving these 5 prime numbers to these 5 elements, and of course, these 5 prime numbers are the lowest possible prime numbers. So therefore, um, you cannot get less sum than that. Like, you cannot do less sum than this. So like, you have the sum is 28. So for an ideal array with 5 elements will have the sum of at least 28. Okay, an ideal array of 5 elements will have a sum of at least 28, right? So if I have an array of 5 length, a1, a2, a3, a4, and a5, so if that sum is like, if this array's sum is a and a is less than 28, then definitely a is not beautiful. A is not beautiful. That is, A cannot be converted into B. Like, A cannot be converted into an ideal array, because the smallest possible ideal array has 28 as its sum, and I can only convert A into another array which has less sum than my array A. Like, I can only convert this sum A to something less than A, but I cannot convert, let's say, 27 into a sum of 28. So that's why if initially the array has sum of 27, then it is not beautiful at all. Okay. So what I simply need to do, like let's say the problem was to check that is the given array beautiful. Like, let's say we wanted to check that is the array a1, a2 up to an, is it beautiful? Then what you would just do, you could just print yes if it's sum. Like, what you will just do is find out the sum of the first n prime numbers. So 2 plus 3 plus 5 plus up to, like, whatever the nth prime number is, nth prime number. And if this sum is less than equal to the sum of array a, the sum of array a, if this is true, then you will say yes. You will say yes, and otherwise you will say no, right? But here the problem is not this. The problem is that you have to delete some elements from the array so as to make the array a beautiful, right? So one more thing we have is that we have to delete some elements from the array to make it beautiful. So now, how do I do that? So let's say that I have initially my array a, like a1, a2, a3 up to an, right? And so basically, what I want is, I want that p1, p2, p3 up to pn. So p1 is 2, p2 is 3, p3 is 5, and pn is the nth prime number. So just consider this array. So like, this is the array which is the minimum possible ideal array, right? So if my sum of a is less than the sum of p, then my answer is no, right? So now I am supposed to delete some elements. Like, I am allowed to delete some elements, and I have to report the minimum number of elements such that my array A becomes beautiful. So let's say that I deleted k elements. Like, let's say I delete the last k elements. Like, let's say I delete these elements, right? So what I want is that the remaining sum of A is greater than equal to the remaining sum of P, right? So what does that mean? I need to maximize this array, the sum A, and I need to minimize the sum P. Like, if I do that, then it has the most chances to give me the right answer. Like, this is the optimal approach. The optimal approach is that I should definitely try that my sum of A is the maximum possible and my sum of P is the minimum possible. So actually what I'll do is, when I'm deleting, Like when I'm deleting these elements, I will try to delete the highest elements. Sorry, I want to I want to maximize sum, right? I want to maximize sum, so I'll delete the lowest elements of A. Delete lowest elements of A, and also I'll delete, since I want to minimize the sum of P, so I'll delete highest elements of P. So if I want to delete k elements, then in optimal condition, I will delete the lowest k elements of A and the highest k elements of P. So basically, what I can just do is I can reverse sort A and I can sort B. Of course, B is already sorted. B is sorted, like I mean P is sorted, but I can reverse sort this A. I can reverse sort this A and try to remove the last elements one by one. And if at any point my sum of A becomes at least sum of P, then I can print the number of elements that I have deleted. Right? And that is my answer. Because I am iteratively checking that can I delete one element, can I delete two elements, can I delete three elements, so and so on. So wherever the first element, like the first time that I get that I can delete some elements, that will be my answer. Okay. So for example, if I have this test case 242 11 2, 242 11 and 2. So what you will do is you will reverse sort this 11 4 2 2 2, and you will generate the prime number array, which is 2 3 5 7 and 11, right? And what you will just do is you will try deleting. So currently the sum is what? The sum of this array is 21, and the sum of this array is 17 plus this is 28, right? So when you delete one element, so this sum will become 19 and this sum will become 17. So therefore the answer is just 1, because you will have to delete one element, and the remaining array, which is 11 4 2 2, this will become a beautiful array. All right. So and of course, like let's say the answer is 2 in this one, right? The answer is 2 in this one. So like for example, we have 2 3 2 4. So I had 2 3 2 4. So I'll reverse sort this. So I have 4 3 2 2, and my prime number array is 2 3 5 7. So the sum of this is 11, and the sum of this thing is 17. If I delete this 2 and 7, then this sum will become 9, this sum will become 10, so it is still not okay. Now if I delete this as well, the sum will become 7 and this sum will become 5. So now this sum has become less than equal to this A sum. That's why we have to delete two elements, and the answer is 2. Okay, so I hope it is clear to everyone and not just Chirag. So if anyone has a doubt, then they can ask me right now. Pradeep says clear. Mohit, is it clear to you? Because you had said that move to D. So I have explained D now. So is it clear? This is easy. Yes. Because like yeah, it is very easy for a div to D. Like, today's contest was pretty easy for a division 2 contest. If I see the ratings. Meanwhile, if anyone who has doubt, then you can write in the chat right now while I am waiting for you all. So this was a very unbalanced contest, like 800, 800, 800, 900, 1100, 1400, 1700. So till E you have only 1700, and like this is not ideal. And directly then F is 2600. So this is not good. Yeah, it is close to 1400. Anyway, so I'm assuming that all of you don't have a doubt, and I'll move on to the last problem of the day, which is problem E. This is called unpleasant strings. Let us call a letter aloud if it is a lowercase letter and one of the first k letters of the Latin alphabet. That is the English alphabet. Like, okay, you are given a string S of length n consisting only of allowed letters. Let's call a string T pleasant if T is a subsequence of S. You will be given q strings. All of them will consist only of allowed letters. For each string Ti, calculate the minimum number of allowed letters you need to append to it on the right side so that it stops being pleasant. A sequence T is subsequence of sequence S if T can be obtained. So you know what a subsequence is. Okay. So a string T is pleasant if it is a subsequence of S. So you are given some strings T1, T2, T3, and for all of them, you have to calculate the minimum number of allowed letters that you need to append to it so that it stops being pleasant. Okay. So this is also a very common pattern, like subsequence matching, like subsequence mapping. If you have heard, like this is not a name, not a common name, but I am calling it that. Like for example, in this div 3 also, the recent div 3, this D problem was of subsequences. Like you had to match this B onto this A subsequence. I mean, you have to match this B onto this A. So here also, you have to match this string T. You have to match the string T on the string S, and you have to ensure that, like, you have to append some characters onto T so that you cannot match it with the string S. Okay. So yeah, that's what your problem is. That basically your string S is given, and some queries are given, like some queries of string T, and for each query you have to tell them the minimum number of characters to append to T to stop it from being a subsequence. All right, the handwriting is too bad, I know, but yeah, the minimum number of characters to append to T to stop it from being a subsequence of S. That is the problem here. So let's look at samples. Like let's say we have ABA, CABA. Okay, we have ABA, CABA, right? And let's say the first query is CC. So how many characters do you need to append to this so that it is not a subsequence of this string? So is CC a subsequence of this string? It is not, because the first C matches with this C, but the second C does not have any match. So this is not a subsequence. So the answer is 0. Like, you don't need to append anything. It is not. It is already not pleasant, or it is already not a subsequence. Sorry about that. Yeah. And let's say we have BCB. If we have BCB, so what you have here is BCB. So this B maps to this B, then this C maps to this C, and this B maps to this B, right? So if you append one more character, like let's say you append a C, so that will be not matching with anything, right? So that's the issue. Like that's what you can do. You can append C here, or you can even append B here, because B will also not match with anything, right? But you cannot append A here. You cannot append A here because that will match with this character, and this BCBA is still a subsequence, right? So the minimum answer is, like, either you can append B or you can append C. So your answer is 1. The answer is 1, right? And let's say you have only B as your query. So your string T is initially only B. Okay. Um, in that case, like this B maps with this B. Okay. So whatever you append now, like let's say you append an A now, so this A would match with this A. And once more, whatever you append, whatever you append A, B, or C, like A or B or C, they will still be able to match, like either to this A or to this C or to this B, right? So definitely, if we try something else, like if here, if we try B, let's say, so B will match here, and then you will try to append C. So C will not match anything. So this BBC is not a subsequence. So therefore, the answer is two, because you cannot do it in one. Like the initial string was B, right? So if you just add A, or you add B, or you add C, it will not work, because if you add A, then it will map with this one. If you add B, map with this one, and if you add C, then it will map with this one. So you can do it in two operations, which is you can add B, and then you can add a C or a B, in fact, right? So this is what your like problem is. Like what you have to do, you have to find the minimum number of operations in order to make it not a subsequence, right? So what should we do? Let's think about that. What should we do? So first of all, like let's say that if I have a string T, if I have two strings T1 and T2, okay, so let's say one of them is AC and one of them is ABAC, right? So T1 is AC and T2 is ABAC. So where do they match? Like let's see. So AC matches here. So A matches this one, and C matches this one, right? And my string ABAC. So A matches here, then B matches here, then A matches here, and then C matches here, right? So these two strings have reached till the same point. They have matched till here, right? So what we actually have to do is that we need to add some characters so that they don't match these characters. Like the further characters do not match with these characters. So my point is that if we have two strings, wait a minute. If we have two strings, let's say T1 and T2, and they both are subsequence, like they both match completely, and the last letter of both of them matches at the same place, like this C also matches as at this place, and this C also matches at this place. So if they match at same place, then I am claiming that the answer is same. Their answer will be same, because all you need to do now is try to not match these characters. Like let's say you can insert C here, insert C here. So you will try to not match these characters. Pradeep is saying, can't you append something that is not in A? Pradeep, actually, they have given us a value of K also. So in this test case, we have this K equal to 3. And K means that only the first three values, I mean, only the first three letters you are allowed to append. So since the first three letters are all there in this string, we are only allowed to append them. So we cannot append D or something. Okay, so my point is that if you are like, let's say we have two strings T1 and T2. So if T1 also ends at this point and T2 also ends at this point, then their answer will be same, because all you need to do in both the cases is to ensure that your new string that you append in T1 and T2, like let's say you append T3 in T1, like let's say T3 is the minimum string that you append into T1. So you need to ensure that this T3 does not match with these three characters. Ensure that this T3 does not match with these three characters. All right. So like whatever you append in here of the minimum length, you can also append to this T2 as well. So their answer will be same. So do you get this point? That whatever is the answer for this T1, I can also use that for this T2. if they both end up at the same position. So actually my answer only depends on where does this T1 end or where does T2 end. So my answer to Ti only depends on where does the mapping of Ti end. Right. So like for every position, the answer is something like the answer only depends on the position where this Ti ends. Right. So what should I do now? Like let's say that I know that Ti ends at some position P. So if I have the answer for P pre-calculated, like if I already have the answer to P, then I'll just print it. Like if I already have the answer that if my T1 is has been matched till this letter P, then I can simply look up that answer from my table and print that for all the queries. So somehow we need to pre-compute the answer for all of these P. Like if my string T ends at A, or string T ends at B, or string T ends at this A, and so on. So for all the positions, I need to calculate my answer, right? But how do I actually do that? So let's think about that. Let's say we have the string ABAC ABA. Like let's just take the sample only. So AB, AC, ABA. All right. So let's say that your string T matches till here. Okay. Your string T matches till here. I mean, matches means that the last element of this string T has been mapped to this A. Right. And then you have to append more characters to ensure that your the remaining string doesn't match with this string, right? And that length should be minimum possible, like what you're appending, that should be minimum possible. So okay, let's say that till here your answer is this, like let's say you have ba, let's say your string is ba, so b would map here first of all, and then a would map here. So now you want to calculate that what is my answer, right? So now what do I do? Actually, now I have three options, right? Either I can have a C in here, or a in here, or a B in here, right? I have just like these three options. What options? Either I can have A, or I can have B, or I can have C as my next letter. Like not just the entire string, just as the next letter I can have either A or B or C, right? So let's say that I insert an A in here. So that would mean that my string has matched till here. My string has matched till here, and we need to match it furthermore with this, right? We need to match it furthermore with this. So if we add A, that is the case, and if we add a C, then my string has matched till here, and we need to make a string which doesn't match with this. So we need furthermore to not match with this one. We need to cover this part as well, right? And if we add a B, then it will match till here, and we need to ensure that it doesn't match with this A. So I have basically three options, right? So what my point is that I want the answer of this thing, right? I want the answer of this thing. So either I can use A and it will cover till here. So I can use my answer till here and add one to it. Like, see, whatever answer is there for these four characters, like if I have covered till here, let's say, okay, I mean, my bad. If I enter A, then I cover till here. So if I have covered till here, if I have covered till here, then my answer is 1, right? My answer is 1. How? I can just append C to then. I can just append C, and it doesn't match with any of these two. So, like, 1 is my answer. So, basically, if I have already covered till here, then my answer is 1, because I can just append C, right? So, the answer is 1. So that means that if I have only covered till here, right, using this BA, and I append another A, then I will need to perform one more operation except for this A. So uh, this A will take one more operation, and plus one more I have to do for this entire string. So essentially what I have done is that I have reduced this problem into this smaller problem. Like, okay, you might say that this problem is smaller and this is bigger, but actually just think of it this way, that you have reduced this problem, like you need to cover this entire string, and you have reduced it to just cover this string. So the answer to this was 1, right? So therefore, if I use an A, if I use an A after this, like if I use an A here, then my answer for this would be 1 plus the answer for this, right? So I have basically three options. I have three options. That one option is that wait a minute. Yeah, so one option is that I can either place an A here and I can use the answer to this, or I can put a B in here and I can use the answer to this, or I can put a C in here and I can use the answer to this. So out of all these three answers, I can just take the minimum possible one. And since I have basically reduced this problem to a smaller subproblem, right? Like if I use this C, then this is a small problem. If I use A, then this is a small problem. And if I use B, then this is the problem. So I have reduced this problem into a smaller subproblem. So I can effectively use recursion. Or in fact, I can use DP to find my answer, where my state would be just that till where have I covered. Like I can store the answer to till where have I covered. So let's say I have covered till ABA. So the DP of ABA, like the DP of 2 would be the answer, if I have already covered till ABA. So how many letters do I need to append more? That is the DP of, that is my DP. So min of remaining plus 1. Um, I think what you mean is the number of remaining elements. So no, that is not the correct explanation, like correct logic, because what you can do, like let's say you have A B C D E F. This is your string S, and your string T is A, right? So you are saying that your answer will be 5 plus 1 6, but actually what you can just do is you can do AFA. You can do AFA. So this A will match with this A, F will match with this F, and A will not be able to match. So your answer is 2. Yeah. So anyways, your logic was incorrect here, but what I was saying is that you can effectively reduce this problem, that if I have matched till here, then what is my answer, to like a smaller subproblem, that if you have already matched till here, then what is the answer, if already matched till here, then what is the answer, and if you have already matched till here, then what is the answer. So like that solves the problem effectively. Like actually it just solves the problem, if you can observe that simply. Like if I want the answer to the ith element, like let's say I have a string s0 s1 s2 s3 up to sn minus 1, and I have already covered till s2. Let's say I've already covered till here. Okay, so my dp of 2. Now after, now like what I can do is I can actually append A, or I can append B, or I can append C, etc. until the kth letter, like depends on the value of k. So out of all of these possibilities, like let's say that in this substring, the next occurrence of A is at S6. Okay, like the first occurrence of A is here. Then that means if we insert A, then we'll have covered till here, right? Like for example, if I have something like ABA, B, B, A. And if I have already covered till here, and if I insert an A, then that means that this A will map till here. So I have already covered till here. So basically, whatever element I append, whatever element I have appended, it will cover till the next occurrence of that element, right? So we can actually use that DP value. So basically, let's say that if we want to update DPI, if we want to update DPI, then if we use the letter J, let's say we use the letter J, okay, and let's say that next of I comma J, next of I comma J means that what is the first occurrence of J after the position I, okay, what is the first occurrence of I after the position I, then we can simply update this dpij. Like if we want to append the letter J after the ith, like if we have already covered till I, okay, if we have already covered till I and we insert the letter J, then my next of ij, like next of ij denotes that after my I, what is my next occurrence of J. So I'll just use that dp, like this will be my dp of next of I comma j plus 1. So my dp of I will be equal to the dp of next of I comma j plus 1, and like the minimum value of this over all possible j. Like I'll try all the possible letters to append after I, and it reduces down to dp of next ij. So this is your dp, and like the value of the current state I only depends on the dp of next of I comma j, and next of I comma j means that after this I, or maybe next of I plus 1 comma j, I'll do, because at the ith, like till the ith we already, like till the ith we already matched, right? So from I plus 1 we need to see. So next of I plus 1 comma j means that I plus 1 onwards, where does the letter j come first? So basically dp of I depends on dp of I plus 1, dp of I plus 2, and like whatever elements are there after I, it only depends on these elements. So dp of I depends on the ones greater than I. So actually I can just evaluate this dp in reverse order. Like I can evaluate dp of n minus 1, then dp of n minus 2, and so on and so forth. So this is your dp. And finally, when you have a string t as your input, like when you have a string t as your input, you can simply see, like you can simply use two pointers and you can match that till where this string t matches string s, and like till wherever your string matches till string s, you can just use that dp, and that will be your answer. So if I show you how to do it on this test case, like aba ca ba, right? So I'll just evaluate the dp for this aba ca ba, right? So this is my string, and let's say I index this 0 1 2 3 4 5 6, right? So let's say I want to calculate the dp of these values, of these positions, right? So first I'll calculate the last one. So what this last one means, that we have already matched till here, so how many more characters do we need to append, right? So that means, like if we have already covered till here, then we can just append any character. We can just append a, b, or c, and it will not match, of course, because there are no more characters to match. So the answer is 1. The answer is 1. Then let's say we have covered till here, then we can insert an a or a c, sorry, we can insert a b or c. because the next occurrence of B or C after this position is never, like B and C never occur. So if we insert them, then our answer will be 1. Like if we can just insert B or C. Then let's say my, like if I have covered till here, then I can just insert C and the answer would be 1, right? Then again, if I have covered till here, if I have covered till here, then I can insert again C and I'll be sorted. Then if I am covered till here, now there's the interesting thing, that if I insert a C, then I will be covered till here, right? So either I can choose dp3, dp of 3, or I can insert an A, so I'll be covered till here. So, or I can choose dp4, or if I choose to put B, so if I choose to put a B, then it will be like dp of 5, right? So whatever is the minimum of this, we'll choose and we'll add 1 to that, and that is my dp of 2. So since all of these three are just 1, the answer to this is 2. Now let's say if we have already covered this A and B, then if we insert an A, okay, then if we insert an A, then we'll be covered till here. So our answer would be 2 plus 1, 3. But if we insert a C, then we would be covered till here, and our answer would be 1 plus 1, which is 2. And if I insert a B, then I would be covered till here, and our answer would be 1 plus 1, which is 2. So the minimum is 2, right? And if I am covered till here only, then I can insert an A. So if I'll cover till here, and if I insert a B, then I'll be covered till here. So in both the cases, the answer is 2. But if I insert a C, then I will be covered till here. So the answer would be 1 plus 1, which is 2. So this is your DP for all of these values. All right. So this is your solution. And now you can just match the string T with string S, and wherever you end up, that will be your answer. And like if your string doesn't match with the string S, like if your original query of the string T doesn't already match with the string S, then your answer will be 0, because you don't need to append any more characters, because it is already not a subsequence. Okay, so yeah, this is your solution to the problem number E. So do you all get this, or is there any doubt? If there's a doubt, then you can ask me right now. Like to implement this, all you have to do is just store the next occurrence of every character after a certain position, like after the ith position. Where does the character J occur? Just store that. So basically, this next array you will store, and it is pretty easy to make this array, right? So everyone, do you all get this? If you get it, please write a yes in the chat, and if you don't get this, please tell me the doubt. If you have a doubt, then tell me a doubt. If you don't understand it at all, then you can rewatch the solution at 0.5x speed and try to pause. Okay, so since there are no doubts coming, I will show the code. All right, so this is the code. um, okay, so you have n comma k, scene n comma k, string s, and scene s, and I have stored the next of n comma k. This is my array. That next of ij means that after the ith index, like including the ith index, where does the jth character come next, right? So initialize, like I initialize all next of n minus 1. Like I'll just initialize the last character, like the last position of every character as n, and n means that they don't occur at any point after this. Okay, so for all the characters I'll initialize to n, and just for the last character, like whatever is the last character, I will make it n minus 1. So of course, for the last character, the next of n minus 1 will be n minus 1, and for the other characters it will be infinity, or it will be n, I can say, right? And for, like, I'll iterate backwards to fill up this next array. For int I equal to 2, I equal to n minus 2, I greater than equal to 0, I minus minus. For int j equal to 0, j less than k, j plus plus. Next of ij equal to next of I plus 1 j. Like I am just copying the next of I plus 1 j to next of I comma j, and like that will be same for all of the elements except for whatever is at the position I. So I'll update the position I next the position I's next occurrence to be at I, right? So that's how you make this next array, and finally you make the dp array. So my dp of n is 1. So what does dp of n 1 means? Wait, so here what you are doing, like, okay, I'll explain this later why dp of n is 1, but first I'll explain the transition. Like for int I equal to n minus 1, I greater than equal to 0, I minus minus. So if next of ij equal to n, okay, like I am iterating on all the characters, all the possible characters. So if next of ij is equal to n, that means that the jth character does not appear after the ith index at all. So I can just insert that jth character and I will be done. So my dp of I will be 1. Like one of the possible answers would be 1 for my dp of I, right? And if next of ij is not equal to n, that means that if I insert this jth character, it will match till somewhere, right? So if it matches till next of ij, like if it is next of ij, then I will use this dp of next of ij plus 1, right? And like I will have to increment this, like dp of next of ij plus 1 and plus 1 I'll do, because I'm also inserting this jth character. So the plus 1 right there. And also, like, I'll take the minimum with dp of I. So because this is one of the possible options. So minimum of dpi comma dp of next of ij plus 1, right? And yeah, this is the dp. And now you do int q c in q while q minus minus. Okay, so actually there is one inconsistency that in this solution. Actually what I meant is that if you have done till I minus 1, like dp of I actually means that if you have done till I minus 1, like let's say you have done till this is 0 1 and 2, right? If you have mapped till I minus 1 and you are yet to map from I, like, then like basically I'll store this answer in dp of 3. I'm storing this in dp of 3 and not in dp of 2. All right, so my dp actually means something else. So in this table every value will be shifted to the right. Okay, so like not to the right, wait, like if I have done till here, then that will be stored in dp of 1. Okay, yeah, so every value in this table will shift to the right. Like actually in my code, that is what I mean, that if I have done till I minus 1, if I have done till I minus 1 and I want to do from I onwards, then that is called dp of I in my code. So that's why this dp of n is 1. Like if I have already done till n minus 1, like if I have already covered till n minus 1, then that means I already also have to cover one more. And like if I insert any more character, then I will be done. So the answer is 1. And like uh, yeah, so dp of I is equal to the min of dpi comma dp of next of ij plus 1. Like so if I insert the jth character. When I've already covered till I minus 1, if I insert j, right, then I will have covered till next of ij. I will have covered till next of ij. So I will use the dp of next of ij plus 1 because that is how my dp is defined. Alright. And I'll add 1 to it. So yeah. And finally, I'll do the queries. So in my query, int q c in q while q minus minus string t c in t, right? And p is equal to 0. So this is my pointer. My pointer in my string s. That till where have I covered till now, right? So for int I equal to 0, I less than t dot size I plus plus, I iterate over the string t. So I will increment the p pointer until my ti becomes equal to s of p, like until I find a match of ti in my string s. So and while p is less than n, so p plus plus. So if p is equal to n, that means that we did not find any match for the current letter of t. So I'll see out 0 because I was not able to find the entire t in the string s. So already the string t is not a subsequence of the string s. So I'll see out 0 and flag equals to true. Like flag means that I've already printed. So I'll not print. Like if I have already printed this value, then I am setting flag equal to true. Right. So yeah, if p is equal to n, that means that while finding t of I, I could not find it in the string s, and I reached the end, so I'll print 0. And otherwise, like I found till p, so I'll increment this p for the next element to process, right? So I'll keep doing this for all the letters t. Like I'll keep doing this for all the letters in t, and finally I'll end up like p will end up at that point where basically it is supposed to, like, basically if we have already mapped till I, then this p plus plus will transfer this p onto I plus 1. So if we have already mapped till I, then we'll reach I plus 1 with this p pointer, and therefore I will just print dp of p because we have already covered till p minus 1 and we want to cover till p more. So the answer for that is dp of p, right? And yeah, we'll do this if not flag. So like if we did not print 0 right here, then only we'll print this dp of p. Okay. So yeah, this is your solution to the problem number E. So if in the code someone has a doubt, then they can ask me right now. So do you all have a doubt in the code? Okay, so since I'm getting no doubts, I'm assuming that everyone got the solution. All right. So yeah, that's it for today. And like today we'll discuss 5 problems, and that's what we we plan to do. So yeah, I'll end this stream now. So bye everyone. Have a great day, or good night rather. Good night.